A big thing mentioned in the previous titration videos was the relationship between pH and pKa. So that is something you'll think about conceptually and sometimes do some math and calculations with to understand what's going on in your solution. So as I mentioned before, anytime we take the quote P of something, that's just the negative log of it. So we can take the pH, the pOH, the pKa, or the pKb. And when we think about the pH relative to the pKa, it gives us a relationship that allows us to know how much hydrogen ion, but also how much acid and conjugate base we have in solution. So the Ka equation is written here. Ka is obviously the product of our ions over the unionized acid. The important idea that we referenced in the titrations video was at the half equivalence point. The half equivalence point, once again, is when half of my acid has been converted into its conjugate base. That's the place where those two concentrations would be equal. And if we look at them in terms of this equation, they would then cancel, leaving our Ka equal to our hydrogen ion concentration. If those two are equal, the negative log of each is equal as well, which gives us some helpful reference in terms of understanding what our pH is, when they are equal to each other, and when we have more of one species than the other. So the fact that we have repeated over and over and over again that is really important to keep in mind, which is why it gets repeated, is that the pH equals the pKa when the acid and its conjugate base are equal. That would be in a titration at the half equivalence point. It's very often asked, when does one become greater than the other? And people are tempted to think about pH values as above or below 7, or to think about the equivalence point. But we need to remember that it is at the half equivalence point that they become equal to one another. So when the pH of our solution is less than the Ka, it's because I have more acid than conjugate base. They're equal when the amounts are equal. So when the pH is lower or more acidic, that's because I have more Ha than A minus. In a titration, that would be before the half equivalence point if we were looking at our first more common scenario of titrating a weak acid, that's in the flask, and adding a strong base to it. When the pH is greater, that means I have more of the base. It doesn't necessarily mean in any of these cases that the pH is above 7. It means the pH is above the pKa for that weak acid. I have more of the conjugate base than the acid itself and the weak acid itself, which is what's giving me that higher pH. So very commonly, you're asked about what is the predominant species. That just means which thing do I have more of, the acid or its conjugate base, or the weak base or its conjugate acid. So the amounts vary based upon the pH, but they are not based upon whether you are above or below 7. And always as a reminder that that 7 is only true at 25. So you're going to be, in these examples, explaining what we have more of and how we know that. It's all about this relationship here. So there's numbers tied to it, sometimes a little bit of math, but much more important conceptually, thinking about where am I relative to my pH and my pKa. So what can that tell me that I have more or less of one species relative to the other?